Okay, let's look at another. So we've already discussed induced matrix norms. We've seen three induced matrix norms, which is maximum column sum, maximum row sum, and the spectral norm. And we've seen that maximum row sum, column sum is induced by L1 norm, maximum row sum is induced by L infinity norm, and the spectral norm is induced by the L2 norm. Okay. Now in this lecture, we'll look at another norm, which is matrix norm. Matrix norm using a similar matrix of similarity. I think the better way to write it is matrix norm using similarity. Okay, this is an important idea, but it's simple. So let's recall. We've already discussed in for vector norm that if this function is a vector norm, on Cn, then if A is non-singular, we can define a new norm, new vector norm, such that it is norm of Ax. Seeing that this is also a vector norm. If proved that it's a vector norm, that it satisfies all the properties of a vector norm. Similarly, in a similar fashion, we have a theorem in matrix norms. If this 3-bar function is a matrix norm, on Cn cross n, and if there exists an S which is non-singular, then we can define a new matrix norm. S is defined as matrix norm of S inverse A is for all C onto n cross m, and so this is a matrix norm. So to prove, let's try to prove this. S inverse A is so this is actually a similarity transform. So given any matrix, S inverse Ax. So this is like a side note. B is similar to A if we can express B as S inverse AS. In this case, we say A is similar to B. Okay, we'll discuss this in more detail later. But let's try to prove this. For the proof, I'm skipping 1A, and 2 are obvious, easy to prove. Let's prove triangle inequality 3 is triangle inequality. So what does it say? We have norm of A plus B, the S norm of A plus B. What is it? This is norm of S inverse A plus B into S. Sorry. Yeah. We can split this up, which is S inverse AS plus S inverse BS. But this is actually a valid norm, right? So we can apply triangle inequality for this norm. So this is less than or equal to norm of S inverse AS plus S inverse BS. So this is equal to normal. So this proves triangle inequality. Now let's look at submultiplicativity. What does it say? It says what we have to prove is norm of S norm of AB, S matrix norm of AB, which is equal to. Okay, so what we can do here is, okay, let's record the definition. This is S inverse ABS, right? Where this is a valid matrix norm. So we can, if S is non-singular, then can insert something like this in between A and B. S inverse, this is typically I into B into S. So again, to group this together, then you can apply submultiplicativity because this is a valid norm. It's less than or equal to S inverse AS, the matrix norm of S inverse BS, which is, in fact, S norm of A into S norm of B. So submultiplicative is also true. So we can prove that this is a valid matrix.